when we go through trig, want to make sure you use radians. But arc sine, how, like in pre-calc, did you guys use arc sine or did you use different notation? What's arc sine the same as? Sine inverse, so it's like sine to the -1. We're going to want to do these without a calculator whenever we can. So this one right here, what's this actually asking? Yeah, what angle gives you a sine of -1/2? So where is sine negative? Like where would that triangle have to be? Quadrant 4. Okay, so sine and tangent run 1 and 4. Where does cosine run?
1 and 2.
Yeah, 1 and 2. So we have a sine down here. What, like using trig, what does sine stand for? Opposite hypotenuse. So what kind of triangle is this? It's a 30-60. So what angle is right there? 30, so in radians. And since it's down, -5/6. True.
It's negative in 3, right? 2. Sine positive in 1.
Yes. So, like, you know how the square root of 5, or what's the square root of 25? 5 and -5. 5 is considered the principal answer, the primary answer. So primary answers for sine and tangent are right here. Cosine goes from here to here. So yes, there is an additional answer over here. But if you're asked for one answer, it's looking for the one that goes right here because that's the main answer. But yes, you are right. There are other answers. So you wouldn't even need to say 5π/6 because it's looking for the one going from your x-axis. So this is going to kind of be weird for me because I think of this as how I teach it in Algebra 2, and you guys have obviously seen it in other ways. So if I'm explaining it in a way that you don't know, ask someone else because you guys know what you've heard for the past 2 years. I only know how I teach it. So in the next one, we need to know what angle gives us a cosine of 0. So what angle gives you a cosine of 0? π/2. Because cosine, if you think about the ordered pairs, like what part of the ordered pair is cosine? Your x. So out of the corners, your quadrantals, which of those has an x value of 0? The top and bottom, that's π/2, 90 degrees. π/2 is your answer because cosine is going to look for the answers in the first and second quadrant. Okay, so then our tangent, this is positive, which is nice. What does tangent stand for? Sine over cosine, or if you just think of it as a triangle. So our opposite is √3, our adjacent is 1, so what kind of triangle is that? 30-60, so what angle would have that tangent ratio? π/3, because it's 60 degrees. Do you guys use SOHCAHTOA with this?
Yeah.
Okay, good. I do too. If you don't, if you have these memorized, good for you. I always draw triangles because I don't know. Okay, the next one, arc sine of 0.3. So what sine angle has an answer of 0.3? Is that going to be a special right triangle? No, because if you were to write that as a fraction, it's 3/10. So sometimes you can't use this, so what would you have to do? Calculator. Make sure your calculator is set in radians. How many radians? So if you did not get that, go to your mode and change it into radians. You're probably just measuring in degrees. So today is like our nice wake up day of trig. The last one, so I'm going to jump down to this one right here. Arc sine of √2/2. That one we know, √2/2. π/4. √2 means it's a 45, 45. Okay, these next ones. It's a composite function, so when you have a composite function, where do you start? On the inside. So what we're being asked is we have some angle, and what is its cosine equal to? So that's what we're given, because this is saying cosine of some angle is root 3 over 2. And just for practice, what number is going to finish out this special right triangle? It's a 1. It's a 30/60. So if this is always half of the hypotenuse. So there's two different ways of doing this. So the first way is, since it's a special right triangle, you guys know this angle. What angle would be in this position in a 30/60? Pi over 6, the smaller angle, so that's the 30 degrees, which is the pi over 6. So this whole part right here, what angle satisfies that? Pi over 6. What is the sine of pi over 6? 1/2. So one way that you could solve it is you could figure out what that angle is, and then be like, oh, I know that sine of pi over 6 is 1/2. The other way you could do it is you don't ever need to figure out what that angle is. You know it's going to have this angle. If you want to then know the sine of that angle, in a right triangle, what does sine stand for? Opposite over hypotenuse, so you get the same answer. So it doesn't matter if you really know this middle angle. It's more about it all comes from the same triangle, so you can figure it out that way. So you guys try this middle guy. So then what's the sine of the arctangent of 3/4? So this is not a special right triangle. So start here, make your triangle, figure out the missing side, then take the sine from that angle. Kind of what you get. 3/5. Questions on the 3/5? Okay. What we're going to do is we're going to learn how to differentiate different equations that you haven't seen yet. We're starting with the transcendentals. If you go to the very last page, or the back side of it, so there are kind of two branches of like names of functions. We're jumping into the transcendentals. So they're kind of the weird ones, the logs, exponentials, trig, and inverse trig. Back to the beginning. So whenever you see something about transcendentals, it just means it's a different type of function. It's not a polynomial or something like pure algebraic. Something we need to be able to do is rewrite something that's trig into something that's not trig. And it all kind of goes back to the triangles. So that parenthesis is in the wrong spot. It should be out here because it's the arctangent of that angle. So we're going to set up those triangles, but we're going to have some variables in there. So we're going to have some right triangle, and we're going to have an angle right here. And we know whatever that angle is, we know that its tangent is x over 2. So tangent is opposite over adjacent, so it's x over 2. We need to find the hypotenuse. What are we going to have to use? Pythagorean theorem. So it's a squared plus b squared equals, I don't know why I do this. I put box squared. I don't know why. Because it's just visualizing like this is the part we need. So if we need this part, how do I isolate my hypotenuse? Square root. So our hypotenuse is actually equal to the square root of 4 plus x squared. Agree? So we're starting at the inside. We're using that to help us fill in a triangle. So we don't know what that angle is, but we want to know the sine of that. So what does sine stand for? What is opposite that given angle? X. What is the hypotenuse? So when it says write these transcendental expressions in algebraic form, this is equivalent to that. Since they, like, we just used it to fill in a triangle, we just wrote it in an equivalent form. This looks like something we've worked with. This is algebraic. This, not so much. So when it says to write in algebraic form, we're using this to help us because this is something we can differentiate. This is something we can work with. On the next one, start on the inside. Arc sine of x. So what that means is sine of some angle has to equal x. So x over 1. Fill in the missing side using Pythagorean theorem. And I don't know if this is why I use the box right here, but for me, I can just visually see how do I isolate that other side. What do I have to move over? Dx squared, and then take the square root. So this other leg is the square root of 1 minus x squared. I think I use the box because then I'm not introducing a new variable. I don't know. Whatever helps you get there, go for it. So now you want to know the secant of that. What is secant the same as? 1 over cosine. I also try to avoid secant, cosecant, and cotangent because why make yourself learn something backwards if you just know you have to put it under 1? So what is the cosine of that given angle? To fix that complex fraction, what's going to happen if it's 1 over this? To make it non-complex, what do you multiply by? Multiply by its reciprocal, because then those will cancel. So this whole thing algebraically is equivalent to and again, we're just rewriting it in another way because then it's something easier to differentiate. Because we're going to be taking the derivatives of these and being honest with you, like, yes, there are canned formulas for this. But when the day comes, you know your trig. You want to bet on your trig rather than memorizing like 40 formulas because we're going to come back to this. So that's why we're building this rather than worrying about like memorizing a formula because that's going to be harder to remember in reality. How we use it to help us differentiate. We want to take the derivative of the arc sine of x. We're going to use implicit differentiation. Do you guys remember what implicit means? Yeah, it changes what it's with respect to, which means we're going to have 2 different variables. So that's where we had like the dy dx that we throw in there. So first we need to write an equivalent formula. So what is this the same as? But instead of using arc sine, let's use sine. So that's the same as saying the sine of what? The sine of y equals x. Because this is saying the arc sine of x is y. And doesn't the arc sine give you an angle answer? So this is your angle. The sine of some angle is y. The sine of y is that. Use this to make your triangle. So it's the same. Arc sine, we're just rewriting it as a sine. This is different because now we actually know what angle we're working from. What's the name of our angle? Y. So the sine from that angle y has to equal x. So we have an x and a 1 because it's opposite over hypotenuse. Do that same trick to fill in your last side of your triangle. So the last side is equal to 1 squared minus x squared. So that's just rewriting it in an equivalent algebraic form. Because that triangle has the same equivalence. We don't want to use arc sine. Let's rewrite it with sine because that's something we're used to working with. This is something we can differentiate. It's the chain rule, but we can differentiate it. what's the derivative of sine? Cosine. So the derivative of this, because in the end, we need to differentiate this. So the derivative is cosine of whatever's on the inside. Implicit means we're going to have a chain rule. We always are going to differentiate with respect to x. So when this is a y, chain rule says, what's the derivative of y? dy dx. What's the derivative of x? 1. So you're asked to find the derivative of it. Remember, this is the derivative. If you can isolate that, you have the derivative of it. So how do you isolate that derivative? So your derivative is equal to 1 divided by the cosine of y. How do you go and get that cosine y? Your triangle. If you look at your triangle, can you tell me what the cosine of y is? Yeah. So it's 1 over 1 minus x squared over 1. Same flip as before. What's that equivalent to? So the derivative of the arcsine of x is right there. So it's not memorizing a formula. It's using processes you already know to help get us there. And I don't know if you guys heard Connor, when you see this right here, is it okay to think of this as secant? Yes, I'm just not as quick as looking at the reciprocals, so that's why I just keep it as 1 over cosine, because it's just quicker for me to look. So whatever you're comfortable with, go for it. We're going to skip these two for now. Go to this page. I kind of put the hard ones in the middle, so let's do some more of the other ones. B. We're going to start with B. So, step 1, you need to find an equivalent expression that doesn't use arctangent, it uses tangent. So what would that be equivalent to? The tangent of, perfect, the tangent of y equals 3x. Because this is saying that arctangent is 3x. From here, you can now build your triangle. The tangent of your angle is 3x. Tangent is opposite over adjacent. Pythagorean theorem will fill it in. So what is your hypotenuse here? Yep. Square root of 9x squared plus 1. So this is something I don't want you guys to memorize the derivative formula for, because you already know how to take the derivative of that. And why learn something new if you can just rewrite it? What's the derivative of tangent? Secant squared. So then, since it's secant squared y, chain rule, yeah. Derivative of 3x? 3. Here's something where knowing the reciprocals is helpful. Secant is really 1 over cosine, so you don't need to think of that. How do you isolate the dy dx? What could you multiply by? Cosine. Yeah. So our next step is, what do we have to figure out? What cosine is. So look at your triangle. Cosine is what over what?
1 over
So cosine is opposite over adjacent. Nope, adjacent over hypotenuse. It's squared, so it's that quantity squared. Yeah, kind of nice. Those are just going to cancel. Where's this 3 going to multiply up to? Try A and C. So take a couple minutes, work with people around you, check answers with them. I'll put the answers up, but try A and C. Don't go on to D.
said I was like, what? Why does this work?
Okay, everyone I saw had that one good. And then for C, final answer should be so far so good. When you divide the cosine over, in the end, where's it going to end up? Yeah, it's just going to be in the denominator with everything else. And then it's really nice when the hypotenuse is a 1, because it's just going to be that. Yeah.
Can you multiply the square root of x into the square root?
Go with the addition in there. That'd be like, can you multiply an x squared into an x minus 3 squared? Right? The exponents are the same. I'm going to say you shouldn't. Right? You wouldn't multiply that x squared in.
When you have like a square root, can't you like take out, it was like 25x,
Did you read? So square root rules.
yeah, that's
I mean, it doesn't really simplify it down anymore. So
no, I can't remember.
yeah, because if you had like root 3 times 4, you can read it as root 3 times root 4.
Yeah.
So I'm going to say yes, but it's kind of pointless. All right, last one. This rule is going to work even if it's with e's or whatever. So if it is a secant, arc secant, if it were me, I would not think of it as arc secant. Yeah, do cosine. Like, so this is really saying that 1 over the cosine of y equals e to the 2x. So then what does cosine equal? Negative exponent's not really helpful here because you want that ratio there to fill a new triangle. What does your hypotenuse end up equaling? E to the 4x minus 1. Sorry, your other leg.
Oh, I was like,
Woo! What's the left side derivative going to be? Negative sine y dy dx. And now, is it helpful to think of this as an exponent, like a negative exponent? Yeah, because that is equivalent to e to the negative 2x, and what's the derivative of that? So then dy dx, numerator, denominator, the negatives will cancel. What sine of y equal to? Go through, simplify.